All right, we're going to start our first section here, 1.1, and this is going to be about graphing equations. In here, you can see a list here of what's going to be in this one. We're going to do some coordinate plane stuff, some examples, some distance formulas, midpoint formulas, graphing equation, finding intercepts graphically. We're going to find intercepts algebraically. We're going to look for symmetry in circles and completing squares and all kinds of stuff here. So let's go ahead and get started. So first off here we have what is called the coordinate plane. And the coordinate plane is used to explore relationships between numbers. It is divided into 4 quadrants labeled counterclockwise by 2 axes. A point on the plane is an ordered pair, noted p x comma y or p equals x comma y. And so it's an ordered pair because the order matters. 3, 4 is not the same thing as 4, 3. So be sure you remember that. And notice the quadrants start here, is quadrant 1, and then you go counterclockwise to 2, then 3, then to 4. So you're ordering them that way around, counterclockwise. Okay, so make sure you're familiar with this. You should have probably already seen this, but anyway, make sure you know it. X-axis, Y-axis, and be familiar with it. Okay, next, let's do a quick example of graphing some points. So we're going to plot the following points. For A, it is -3, 2. So just so you remember this first ordered pair, the first number tells you where it is on the x-axis. The second number tells you where you go on the y-axis. So for the x-axis, we're going to go over here to -2. Oh, I'm sorry, not -2, -3. And then on the y-axis, we're going to go up here to 2. And then we just come across to where they meet. And that's our point right there. Okay, and that's pretty much it. For B, it's the point 3, 2. So now we're going to +3, which is over here, and up to 2 again, and where they meet is right there. I'm going to start doing these a little faster. For 0, that's going to be at 4, 0, 0 on Y, 4 on X, 5, -1, or -5, -1, -5, -1, that's right there. Okay, so maybe I'll put a dot next to them. I should have done that for the colors, huh? That's that one. That's that one. This one I did in black. All right. 0, -3, I'll do in red. So it's 0 on X, -3 on Y. There we go. Go with the green here, 0, 0. That'd be right there. Also want to get rid of those lines. They're looking a little confusing. And then finally, we'll do one here in orange. 11/2, which is about 5.5. So that's about right there. Right there. And then -10/3, which is about 3 1/3. So down to here. So somewhere about right there. It doesn't have to be exactly on a number, but somewhere like that. All right, and there's all those points plotted. Sometimes point F is sometimes called the origin. That was this one right here, point F. It's that point 0, 0, right where your 2 axes meet. All right, next let's take a look at the distance formula. If you remember, the Pythagorean theorem gives us a relationship between the legs and hypotenuse of a right triangle. Okay, of a right triangle, where one of the angles is 90. And what this tells us is this here, a squared plus b squared equals c squared, when we're looking at in other words, the square of the 2 legs added together is equal to the square of the hypotenuse. All right, and this is essentially very geometric in that if you look at this, if we took this side A and we extended it out this way and made it into a square, so it's A by A, and we took the side B here and we extended it out into a square, so it's B by B by B by B, and we took this side C and did the same thing, made it into a big square, right? C by C like that, we would have three different areas, three different squares there. And we could say this is area of A, area B, and area C. And it turns out that area A plus area B is equal to area C every time for a right triangle. And you find the areas by doing, over here, this is A squared. That's how you find the area of a square. You multiply you square the length of the side. This would become B squared. This would become C squared. And so that gives you the Pythagorean theorem right there. A squared plus B squared equals C squared. All right, next. Let P equal x1, y1, and Q equal x2, y2 be any 2 points on the coordinate plane. Then the distance formula, the distance between points P and Q, denoted dpq, is given by the formula, and we've got it right here. So if we take a look at this, if we're looking for the distance between this point here and this point here, and so what's been done is this has been made into a right triangle, where the hypotenuse is this distance right here, dpq, the distance there, and so then that distance squared has to equal the distance from here to here squared plus the distance from here to here squared, right? And so we can just go ahead and write that out. We can say the distance here, this distance right here, is just x2 minus x1 squared, right? That's the distance, is x2 minus x1, and then we square it, plus this distance over here, which is the absolute value of y2 minus y1 squared. Really don't care that much about the absolute value because when we square it, it's just going to go away. And so we can take the square root of both sides, and we get the distance from P to Q is equal to the square root of, since we don't care about that absolute value because we're squaring it and everything squared becomes positive, y2 minus y1 squared, just like that. Okay? And there's your distance formula. And quite often it's even just written with just a D instead of dpq because it's not always the points P and Q. So we'll generalize it just a little bit more there. And that's it right there. There's our distance formula. It's essentially just the Pythagorean theorem. So as long as you can remember that's what it is, you should be able to do it. All right, let's take a look at an example here, finding the distance between 2 points. Here we're going to go ahead and write down this distance formula again. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And it doesn't really matter if you do y2 minus y1 squared plus x2 minus x1 squared. That order doesn't really matter. And it also doesn't matter the order for which you subtract these either because you're squaring it. So if you reverse the order, if you did x1 minus x2, you'd just end up with something with the opposite sign, but when you square it, it goes away. It's all just going to be positive. So let's try this one. I'll do A, and then I'm going to leave B for you to try. So distance is equal to the square root of x2. So this is x2, right? x2. So 2 minus x1, this is x1, minus negative 1 squared plus y2, which is negative 3, minus y1, which is a negative 5. So you have to be really careful and meticulous with your negative signs, and we end up with 2 minus negative 1 becomes 2 plus 1 squared, plus negative 3 minus negative 5 becomes plus 5 squared. and then 2 plus 1 is 3, so we have 3 squared, plus negative 3 plus 5 is 2, and so we have 2 squared. So we end up with 3 squared, which is 9, plus 2 squared, which is 4, and so we end up with the square root of 13. Okay, and there's our distance right there. I'm going to leave that next one for you to try and see how you do. So next, let's take a look at the midpoint formula. So this one's pretty simple. When you want to find the middle point, the center between these 2 points, we can again turn to drawing a right triangle to kind of visualize this. And you can see if we come over here on just this leg right here, and sorry, my alarm going off there. If we come over on this leg right here, and we go exactly halfway on it, right in the middle, and we come over to this leg over here, and we go exactly to the middle on this, look at this. It's going to point right to what is exactly in the middle of our normal line. So that's what we need to do. We need to basically find the middle in the x direction and the middle in the y direction and combine them together to get the middle of our actual line segment. And so how do you find the middle? Well, if we're looking, this is x1, this is x2, and we need the middle between them. How do you find the middle between two numbers? Well, simple. You just average the two numbers. You add them up and you divide by 2. So this middle point right here is going to be x1 plus x2 divided by 2. And then over here, this point right here is going to be y1, and this point over here is going to be y2. And again, we need right in the middle, and going right in the middle there, you just average those two together. So it's y1 plus y2 divided by 2. And so we can then go ahead and write our midpoint, with a capital M there, as the x-coordinate is x1 plus x2 divided by 2, and the y-coordinate is y1 plus y2 divided by 2. You're essentially just averaging the x values and averaging the y values. Average the x values, it tells you the x value of the midpoint. Average the y values, it tells you the y value of the midpoint. So that one's pretty simple, but let's go ahead and try using it. I'm going to copy this real quick, bring it with us to the next page. All right, so on this next page, we'll put it right up here. There we go. We have our midpoint formula, and here we want to find the midpoint. Again, I'll do the first one for you, and then I'll leave the next one for you to try. All right, so let's take a look here. P -1, -5, and Q is 2, -3. Now, keep in mind they don't have to always be named P and Q. So let's try midpoint. Oops, I'm still on that. Midpoint equals. So we'll call this x1, x1, y1, x2, y2. So we'll add the two x1s together, -1 plus 2, and divide by 2. We'll add the two y's together, -5 plus -3, divided by 2. -1 plus 2 is 1, and so we have a 1 over a 2. -5 plus -3 is -8, so we end up with -8 over 2, and then we can just reduce this. This is 1/2 still, but this becomes a -4. And that right there should be our midpoint. If we wanted to sketch this real quick, right? We want to sketch this, we're going to be more down here. So let's make it look like this. So there's our x and y axis. So our first point is -1, -5, 1, 2, 3, 4, 5. So it's right here about. Our second point is 2, 3, so 2, -3, so 1, 2, and then over to -3 like that. So these are our 2 points. If we connect them, right, you can see that our middle of it is maybe about right there, right? Maybe right there, right about there. And if we go to the point 1/2, and we go to the -4, right there, look at that. That's right about where we landed just by eyeballing our midpoint. Okay, so that worked. Okay, so try that next one on your own and see how you can do it. Next, let's graph an equation. An ordered pair AB is said to satisfy an equation with variables x and y if, when A is substituted in for x and B is substituted in for y, the resulting statement is true. So here, does negative 2, 1 satisfy the equation y equals x squared minus 3? Well, let's plug in 1 for y and plug in negative 2 for x. I always put parentheses around it, especially if it's a negative number, just so I don't make the mistake, because this does not equal this. This one is positive 4. This one is negative 4. Okay? So don't get those confused. I always put parentheses around when I'm plugging in a number for a variable, especially if it's negative. Okay? It's a good habit to get in. So that minus 3. So negative 2 squared is 4 minus 3. And this would be 1 equals 1. And there you go. Remember, when you're trying to show that two sides of an equation are equal, you want to always only work on one side of the equation, so you don't get something like this. Like, I'll prove that 3 equals 2. If you do algebra to both sides to show that two sides are equal, well, then I can just do this. I can just multiply both sides by 0, because what you do to one side, you do to the other. And hey, look at that. 0 equals 0. It is true. Therefore, 3 must equal 2. Right? That doesn't work. So when you're trying to show two sides of an equation equal, limit yourself to working on one side so you don't end up with some sort of mistake like that, okay? An ordered pair that satisfies an equation is called a solution. Is the point 35 a solution to the equation y equals x squared minus 3? So, well, we're just going to do the same thing. We plug it in. So 5 equals 3 squared is 9 minus 3. That's a 6. This is a 5. And the answer is no. All right, no, not a solution. All right, I'm going to leave, well, no, that's not the question. I'm going to leave that. In the equation y equals x squared minus 3, the x is called the independent variable and y is called the dependent variable. Those are important terms to be able to remember, especially even just thinking in, science research. Your independent variable, which is the x, that's the value you're inputting. It's the thing you're choosing. It's independent. You pick it on its own. And then you get y as the dependent variable because it depends on what you chose for x. So for example, if I choose 2 for x, then I get 4 minus 3 and y ends up being 1. But if I choose 5 for x, then I get 25 minus 3 and y ends up being 22. So y depends on what you pick, independently pick for x. So x is the independent variable, y is the dependent variable. So how many solutions does an equation in two variables have? Essentially infinite. Infinite. We can put an infinite number of ordered pairs. That doesn't mean every ordered pair is a solution. It just means that as you keep doing it, there's an infinite number of them that you can find that will solve it. And so to show all of these solutions, we're basically going to have to graph them, draw a picture, because we can't write out an infinite number of ordered pairs in order to show it. So we'll have graphs that'll look like lines like this. We'll have graphs that'll look like a parabola like that. And we'll have graphs that look like absolute value like that. Okay, and those three shapes there, you're going to have to be very familiar with them and make sure you know them. So let's first try graphing by sketching. I'm just plotting some points and figuring out what they are, and then plotting out the points and figuring out the basic shape here. Now this one I'm familiar with. It's going to be a parabola, so it's going to look like this one here, not necessarily pointed upwards, but that kind of a shape, because I see that x squared there. But let's go try some points. So let's just start with something. Let's start with negative 2. If we plug that in, we get y equals negative of negative 2 squared plus 1, and that's going to equal a negative 3. So we get the point negative 2, negative 3. We can plug in the point negative 1, and we get y equals negative of negative 1 squared plus 1 equals 0. And we get negative 1, 0, just like that. And then you can try 0. And when you plug in 0, I'm going to stop writing that all out just for time's sake. You plug it in, and you'll end up getting 1. So you get the point 0, 1. Then you can try plugging in 1. And when you plug it in, you're going to get y equals 0. And so you get the point 1, 0. And then you can try plugging in 2. And 2 is going to give you y equals negative of 2 squared. So negative 4 plus 1, which is a negative 3. And so you get 2, negative 3, just like that. If we come along and graph these points, plot them out, we get the point negative 2, negative 3, that goes right there. We get the point negative 1, 0, that goes right there. We have the point 0, 1, that goes right there. Oops, I messed this point up. It was negative 1, 0 right there, sorry. Then we have the point 0, 1, which we'll put right there. Then the point 1, 0. And then the point 2, negative 3 right there. And this is definitely not a straight line. We can't fit a straight line to it. It's not the V-shaped absolute value one either. It is, like I said before, it is the parabola. So it's going to do something like that. Okay? I will leave the next one for you to try, but you should get a parabola that is shaped like that and is pointed upward. Okay? And I believe, just as a quick sketch, I shall put it right here just for you, just so you have an idea. It's going to look something like that. It's going to be down there and going up like that. Okay? So it'll look something like that, but go on in there and give it a try and see what you get. And plot some points and graph it. Same thing for the next one. This next one you should try. I can tell by recognizing this graph, it's going to be a straight line. And so for this one, you're going to get something that looks something like that. That's just a straight line. But try that one, plot some points out. It's a straight line, so you don't need more than 3 points to get it. Really, you don't need more than 2 if you're certain it's a straight line. Try that and see. For this next one, it tells you which point to plug in. Plug them in and try. You should get a V shape, something like that. But plug them in and see if you can plot them out and find that same shape. All right? So there's a few for you to try. Next, finding intercepts graphically. Here we're finding where it hits the X or Y axis. And you can see here, we're just looking at where it actually crosses it. So let's take a look at this next point. And let's go with x-intercepts first. All right, so x-intercepts. And when we look at this, use a little highlighter here. The x-intercepts occur here, here, and here. Right, just like that, those 3 points. And we can go ahead and then say that the x-intercepts occur at x equals, that's negative 3, that's this one, x equals 0, and then x equals 3 right there. So you could say that, but sometimes it might want the ordered pair, in which case it's negative 3, 0, 0, 0, and 3, 0. Notice the y-coordinate for all the x-intercepts is 0. All right, so now let's take a look at the y-intercepts. We're going to have one right there, one right there. Ooh, I can't draw over that green. Let's get that light blue here. One right there, there, and there, these 3 places. Those are our y-intercepts. So y-intercepts, we can say it's at y equals 2, 0, or negative 2. Or you could write them as ordered pairs, in which case it's 0, 2, 0, 0, and 0, -2. And notice for the y-intercept that every time it's a 0 in the x-coordinate, okay? So I'm going to leave that next one for you to try. There should be 2 x-intercepts and 1 y-intercept, so just pick them out off the graph and write their ordered pairs. Next, let's talk about how do we find them algebraically. Algebraically, we're going to take advantage of this idea over here where we notice that for the x-intercepts, y is always 0, and for the y-intercepts, x is always 0, okay? So to come over here and do this algebraically, we're going to take advantage of that. For the y-intercepts, we're going to set x equal to 0 and solve it. So we'll get y equals 0 squared minus 2 times 0 minus 15. So this is 0 minus 0 minus 15. There you go. And so our only single y-intercept here is 0, -15. There we go. That's it. For x-intercepts, it can be a little bit trickier. Since we're dealing with functions here, we're going to set y equal to 0. So here you do y equals x squared minus 2x minus 15, and now solve it for x. This can be factored. We can make this x minus 5 times x plus 3, because -5 plus 3 is -2, and 3 times -5 is -15. So that tells us then that x equals 5 or x equals -3 will solve that for us. So those are our zeros. So we have the point 5, 0, and -3, 0. And those are our solutions for the x-intercepts. Okay, that was x-intercepts. That was y-intercepts. I'm going to leave this next one for you to try. This is actually the equation for a circle, as you're going to see soon. And so you should have, ultimately this, you should have 2 x-intercepts and 2 y-intercepts. All right, so give that one a try and see if you can figure that one out. The next page here is a little assignment that goes along with your reading. As you read through pages 57 to 59, I want you to complete the following information. Get that all completed and done, and then determine if those have the symmetries that it is asking for. So this is just a little work for you to try on your own. Next is circles. Also, just one last thing. It is important to understand and know this symmetry, so if you're having trouble with it, you'll want to let me know. But for the most part, it's not a real difficult concept, so just read through it real quick and you should be able to do it pretty quickly. All right, so circles. A circle is a set of points in a Cartesian coordinate plane that are fixed a distance r from a specified point hk. The fixed distance r is called the radius of the circle, and the specified point hk is called the center of the circle. We obtain a formula for the standard form of the equation of a circle with center hk and radius r. All right, so basically our normal equation for a circle is x squared plus y squared equals r squared. All right, and you would have just previously seen that. Where is it? In this example, you should have found that this was a circle. Okay, and then that would be our normal amount. But what we're going to have to do here is actually shift this in the x direction. So we're going to shift this equation because we don't necessarily have to. This x squared plus y squared equals r squared is one that has a circle that's centered at the origin, but they're not necessarily centered at the origin. So we can shift in the x direction by h and shift in the y direction by k. And what we'll end up with is x minus h squared, that's a shift in the x direction by h, plus y minus k, that's a shift in the k direction, or in the y direction by k, equals r squared. And this form of a circle is called the standard form. Okay? Pretty common one to see. It's nice. You can read the center of the circle right off of it and the radius right off of it. However, that's not the only form of it we could have. You could actually have this by, you could actually expand that standard form by squaring all of that out and combining any like terms. And basically, you might have the general form of an equation just by expanding it, or you might come across it, expand standard form, or you might just come across an equation that looks something like this: ax squared plus by squared plus cx plus dy plus e equals 0. And if you have something like that, and if a does not equal 0, and a equals b, then it's a circle. No, not two L's. Then it's a circle, okay? So if that's the case, you can just then divide everything by a to get, and we'd have a what is called the general form of a circle, and it's x squared plus y squared, because a and b were the same, so when we divide by a, it cancels out for the coefficient in front of x and in front of the y, plus, and we'll call this little ax plus little by plus little c, and that's going to equal 0. And this is your general form. If you want to go back to the standard form, right, note, complete the square. You can do completing the square on this in both x and y. So you have to do completing the square twice to get standard form from the general form. Okay, so it's kind of can be a little bit of a pain, but you can do it. So just go through and do that. Now I'm gonna copy this here just real quick so we can take it with us to the next page. Copy. All right, we'll put it right up here because it says find the standard form of the equation of the circle, right? And if you remember, that was our standard form right there that I wrote at the top. That's the standard form. So let's take a look here. It tells us the center is at -3, 4 and has a radius of 7. So it's telling us that h equals -3, k equals 4, and r equals 7. So we're going to do x minus h, so minus -3 squared, plus y minus k, right, might just minus that 4 squared, equals the radius squared, okay? And that's what we have. So this is going to be x minus -3. This becomes x plus 3 squared plus y minus 4 squared equals 49. And there's your answer right there. Okay? So not too crazy, not too bad. Now the next one is a little bit trickier. I'll do some of this for you, but I'm going to leave, or at least I'm going to tell you what you're going to want to do. You're going to want to combine a few of the things that we've done. First, excuse me, you're going to want to find the distance between the 2 points. And when you find the distance, so find the distance, do this, x2 minus x1 squared plus y2 minus y1 squared. Find this distance, and this is going to equal, all right, you find it, do whatever you have to do. It's going to ultimately give you square root of 100, however many steps it tells you, which is going to equal the diameter. Okay? And so when you have the diameter equals 10, right? I didn't need to put square root of 100, huh? It's going to be square root of 100, but it's ultimately just 10. That tells you that's the diameter, okay? And if the diameter equals 10, if the diameter equals 10, then the radius, which we'll just call r, equals 5. It's half the diameter. So now you have the radius right there. So there's r, right? Now you just need to find the center point of it. You need to find the middle of the actual graph, of the actual line, sorry. So do the midpoint. That's going to be your center of your circle. And you're going to do the x2 plus x1 over 2, y2 plus y1 over 2, and find that midpoint. Okay, do what you need to do to find the midpoint, and then plug them into the equation, right? X minus something squared plus y minus something squared equals 25, right? And essentially what you're going to get is you're going to get, some points here, and you're going to look for this is going to go right there, this is going to go right there, and then this, I wrote the 25, it's going to be that something squared. You're going to put that one right there, okay? I hope that makes sense. And then that should be your answer, okay? So go ahead and give that a try, find that midpoint, finish finding that diameter and all that stuff, and plug it in and see if you can get it. All right. Graphing a circle. The first one is the unit circle. I think you should know how to graph that one at this point. So it's not too crazy difficult. It's going to be centered right at the middle. And really, if I draw it where it's 1, 1, 1, it's just going to be like that. 0, 1, 1, 1, 0, 0, 1, negative 1, 0, and 0, negative 1 are those 4 points there. But try graphing that one, and you should see that you could even maybe make each of the little squares worth 2 or something like that, or each of, like 5 of the little squares equals 1 or something like that to make the circle bigger. But that one's not crazy difficult. We just know that, if this is in x minus h plus y minus k form, like that, then we're saying this is x minus 0 squared plus y minus 0 squared equals 1 squared. So the radius is 1, h and k are 0, so that's the circle you get. All right, so let's look at one a little more interesting, which is this next one. And this is x plus 2 squared plus y minus 3 squared equals 25. So again, remember, this has to be x minus h, and this needs to be y minus 3, and it's already a minus, so we're good there. And then this is r squared. So when we go to do this one, we're going to write this in a different form. This is, instead of plus 2, we're going to write minus negative 2 squared. This is already a minus, so we can just leave it as y minus 3 squared. And then 25 square rooted is 5. There we go. And then squared. So that tells us h equals negative 2, y equals negative 3, and r equals 5. So negative 2, not negative 3. Negative 2, 3, like that. So negative 2 and then up 3. There's our center. And then the radius is 5. So we can just go 5 in all the directions. 1, 2, 3, 4, 5 right there. 1, 2, 3, 4, 5 right there. 1, 2, 3, 4, 5 right there, and 5 down. 1, 2, 3, 4, 5. Those are all going to be on our circle, and we're just going to connect it with a nice circle just like that. And there you go. I'm going to leave that next one for you to try. You try and get that one done and see how it goes. And then after that, we have some stuff on completing the square. And I want you to do that on your own. If you have trouble with it, let me know, but it's a skill you need to have moving forward. It's nice. You'll have a way to do it where it's done with pictures, and hopefully that'll help you remember it for going all time. And then the last thing is here that you got to do on your own is that I want you to do this on your own as well. This is, you're going to take this, you're going to do completing the square, which you just learned on the previous page, do it twice, and turn this into general form and draw the graph, okay? And so that'll see how well you got that figured out. All right, that's pretty much it for this video, so thank you very much.